Okay, so now we are talking about different figures. They're still quadrilaterals and they're still parallelograms, but this time they are special quadrilaterals and parallelograms. They are rhombuses, rectangles, and squares. And the interesting thing about these is that squares are special rectangles and squares are special rhombuses. And since all three of these are parallelograms and quadrilaterals, squares are actually rectangles, rhombuses, parallelograms, and quadrilaterals, and squares. So it qualifies for a lot of things there. So let's look at these characteristics here and talk about classifying some of these figures. And then I think we do have a few workamouts at the bottom, and I went ahead and added a figure down here to save us some time on the video. All right, so rhombuses, rectangles, and squares share some characteristics, but they also have some unique features. A rhombus is a parallelogram with 4 congruent sides. So this is a rhombus. Some of you may call it a diamond, but the geometric name for it is rhombus. Notice that it has 4 congruent sides, and so does a square. So a square is a special rhombus. All right. A rectangle is a parallelogram with 4 congruent sides, but these angles are all right angles, okay? I'm sorry, 4 congruent angles, not 4 congruent sides. I think I misspoke. So a rectangle does have 4 congruent right angles. Notice that a square does also, which means a square is a special rectangle. So a square is a parallelogram with 4 congruent sides and 4 congruent angles, so it is both a rectangle and a rhombus. A square is the only type of rectangle that can also be a rhombus. So here is a Venn diagram to help you see the relationships. This circle on the left, it does overlap the circle on the right, but the circle on the left is a rhombus, the circle on the right is a rectangle, and notice that the square belongs to both categories, so it's in the overlap. There are some special features for each type. In a rhombus, the diagonals are perpendicular, and the diagonals bisect a pair of opposite angles. If this is not already in a figure here, I'm going to add it to this figure above. Okay, I'm going to add it. All right, so the diagonals. I'm going to go ahead and add diagonals to this rhombus. Okay, I'm going to throw a second diagonal in here. Okay. All right. No, I don't want to do that. I'm going to freehand. Okay, so one of our special features down here in a rhombus is that the diagonals are perpendicular, which means they meet at a right angle. Actually, they made it 4 right angles, so that's a right angle. This is also a right angle. This is also a right angle, and this is also a right angle. Okay, so they're perpendicular to each other. And the diagonals bisect a pair of opposite angles. They bisect a pair of opposite angles, okay? Which means that the diagonal bisects this angle here, which means that's congruent to that. And that is congruent to that, okay? Oops, that curve didn't work out super well, okay? All right, so this one works out the same way too. So that angle is congruent to this angle, so it's bisected. And this one is also congruent to that angle. Okay, so it's pretty marked up there. All right, so for rectangles, it says the diagonals are congruent to each other, okay? So I'm just going to freehand these. They're not going to be straight. I apologize in advance. That diagonal equals that diagonal, okay? Equal diagonals. I'll try to write a little bit faster so we're not on this one forever. Diagonals. I probably should have typed this one. Sorry, guys and gals. Okay. In a square, all kinds of fun things. Since a square is a rhombus and a rectangle, you have all of these things. Congruent diagonals. You have the diagonals perpendicular, and you have the diagonals bisecting a pair of opposite angles. So the diagonals form 2 45-degree angles at each vertex, okay? So if I marked all of that up here, you wouldn't be able to see the square anymore. So we're just going to, we're actually going to do another resource in class to make sure that it firms up all this information. So the exercises down here says determine or decide whether the parallelogram is a rhombus, a rectangle, or a square, okay? So on number 1, we notice that the opposite sides are congruent, but all 4 sides are not congruent, which means it's not a rhombus, and it's not a square, which means it must be a rectangle, okay? So we will go ahead and type that one in the interest of time here. This one is a rectangle, okay? On number 2, we have 4 sides that are congruent, but it does not show right angles. So we cannot assume it's a square. We can assume that it is a rhombus, okay? So that one is a rhombus. And number 3, again, we have the 4 sides that are congruent. So again, this one's going to be a rhombus. And then on number 4, we have the 4 congruent sides, and we have 4 right angles, so this one is definitely a square. We could actually say that it is a rhombus and a rectangle too, but the most specific name for it, we want the most specific name. Use the most specific name. Most specific name. Okay? And square is the most specific name there for number 4. All right. Okay, so properties of rhombuses, rectangles, and squares. List the quadrilaterals that have the given property. We're choosing among these parallelogram, rhombus, rectangle, and square. Opposite angles that are supplementary. Well, let's look at these things, okay? Opposite angles supplementary. So in a square, opposite angles, since all the angles are 90 anyway, 90 and 90 is 180. So that would be true for a square and for a rectangle, okay? So opposite angles are supplementary in a square and a rectangle. So for 5, we're going to say square and rectangle. Square and rectangle. Okay, and I'm going to need to switch colors here in a minute. But let's go ahead and do 8 in blue because it's opposite it anyway. Consecutive angles congruent. Consecutive angles congruent. Well, that's true in a square. It's true in a rectangle. It is not necessarily true in a rhombus unless the rhombus is a square. So square and rectangle work on that one, and not necessarily true in a parallelogram unless it's a square and a rectangle. So square and rectangle are what we want for this one as well. Square and rectangle. Okay, let's pop on over here and pick a different color. How about this orange? Is that an orange? Kind of looks orange. Okay, so consecutive sides congruent. Consecutive sides congruent. Not opposite sides, but consecutive sides. Consecutive sides are congruent on a square. Consecutive sides are congruent on a rhombus. Consecutive sides are not congruent on a rectangle unless it's a square. And they're definitely not congruent on a parallelogram unless it's a square. So square and rhombus are what we're looking at for number 6. Square and rhombus. That is kind of a pretty color. Oh, rhombus. And then consecutive sides perpendicular. Consecutive sides perpendicular. That's going to be true in our square and our rectangle. So squares and rectangles are, well, they're pretty special. Square and rectangle. Okay. Hope you guys feel okay about that. You can use properties of rhombuses, rectangles, and squares to solve problems. So looking at this one, it says determine the measure of the number of angles in rhombus DEFG. That must be a G. It's kind of rubbed off there. It says that angle 1 is part of a bisected angle. Well, if that angle is bisected, then if this is 48, then that's 48. And it says angle DFG is 48, so angle 1 must also be 48. So consecutive angles of a parallelogram are supplementary. So angle F, or angle GFE, is 48 plus 48, which is 96. So if this is 96, then angle DGF must be 180 minus 96, or 84. So they've shown you all that here in the problem. And the diagonals bisect the vertex angle. So the measure of angle 2, if this is 84, it's 84 divided by 2, which is 42. Okay. All right, so we have some exercises down here to work, 9 through 18. I will try to do this as quickly as I can while at the same time trying to explain it as best that I can, because that's the whole point of doing these videos. Okay, so 9 says determine the measure of the numbered angles in each rhombus. Okay, so this is actually just like this problem right here, okay? So we know that the diagonals bisect the angles, which means that angle 1 must also be 35. Diagonals bisect the angles, and consecutive angles are congruent. Or, I'm sorry, supplementary. So the diagonals bisect angles. And the other note that we're working with here is that consecutive angles are supplementary. Okay, so we're going to use that information here and work things out. Okay, so, and we know that angle 1 must also be 35 degrees. Okay, which means this whole angle here is 70. So this is 70, which means this one is going to be 180 minus 70, or 110. Okay, 110 and 70 are supplementary, that up to 180. So if this whole thing is 110, then 2 is going to be half of that, because the diagonals bisect the angles, which means half of 110 is 55. So this angle will be 55, which means that angle 2 is also 55 degrees. Okay. Not loving this color like I did earlier, so I'm switching. I'm going to go back to that pretty blue. Okay, I think I actually chose a darker blue, which is fine. Okay, so we have angle 1 at 35 degrees here, and we have angle 2 at 55 degrees here. Okay, all right, so for 10, these are rhombuses. We know that, you can actually scroll back up here and see that the rhombus, the diagonals are perpendicular, and they bisect the angles. Okay, so we have the diagonals that are perpendicular here. I presume that this 2 is indicating this angle right here, which we know is 90 degrees. So angle 2, or the measure of angle 2, the measure of angle 2 is 90 degrees. Okay, and it looks like angle 1 is this one right here. So we're going to need to do a little math here. If we know that this angle is 12, then we know that this angle is 12, which means this whole angle here is 24. And if that whole angle here is 24, then we need to find 24 supplement to get this angle together. So 180 minus 24. 180 minus 24. 180 minus 20 is 160. 160 minus 4 is 156. So this angle that I've circled here is 156. And angle 1 is half of that because the diagonals bisect those angles. So the measure of angle 1 is going to be 156 divided by 2. 156 divided by 2. Which is, C2 goes into 15 7 times. 7 times 2 is 14. There's 1 left over. 1, 6. 2 goes into 16 8 times. So angle 1 is 78 degrees. I hope y'all followed that. Saving. If not, watch it again, this video, so you can watch it over and over again. Determine the measure of the numbered angles in each of these figures. So here we have a rectangle. One thing we do definitely know about a rectangle is that all the angles are right angles. So angle A is a right angle, angle D is a right angle, angle B is a right angle, and angle C is a right angle. And we do show that the diagonals have split these angles. So if this is a 30-degree angle, that means that angle 1 is 90 minus 30. Angle 1, measure of angle 1, is 90 minus 30, which of course is 60. I hope that y'all think it's worthwhile for me to take the time to write this stuff out. It's helpful to somebody. Okay, so we know that angle 1 is 60 degrees. Also, a rectangle is a parallelogram. And here we have parallelogram, parallel lines cut by a transversal, and you see that this 60 is actually alternate interior to this 60, which is true also for this 30-degree angle here and this angle 2 here. Those are also alternate interior angles, so we know they're congruent. Of course, we also know that 90 minus 60 is 30, so we know that angle 2 is also 30 degrees. Okay? All right. So how are we going to know what these other two angles are? Okay. Well, angle 4, these are going to be the same angles, and these are going to be the same angles. You can see that this is kind of a mirrored pair here. 2 and 4 are going to be the same, and the 3 and the 60 are going to be the same. So 4 is 30. Sorry. I don't think I'm on bold type, though. And then 3 is 60. Okay. I hope y'all can read that. I guess I could type it out just to be sure. Angle 1 is 60. Angle 2 is 30. Angle 3 is 60. And angle 4 is 30. Okay, so let's look at square LMNO. Square LMNO. Now, neat thing about a square, since a square is a rhombus, then the diagonals are perpendicular. So angles 1 and 2 here would be 90 degrees. Let's go ahead and type that up here. Since a square is a rhombus, the diagonals are perpendicular. Perpendicular. So angle 1 is 90 degrees and angle 2 is 90 degrees. Okay? Now angle 3 is a bisected right angle. Let's type that out. Angle 3 is a bisected right angle. So it is 45 degrees. Okay? Saving, I think. Save. All right, we got 6 more down here, and this is the one that I drew in the rectangle for. Rectangle TUVW. Find the value of x and the length of each diagonal. So let's go look up here at a rectangle's diagonals. Was there a note about that? The diagonals are congruent. Well, that's handy. Okay. In a rectangle, the diagonals are congruent. So 13, do these all do the exact same thing? Okay, so these all give you an equation for diagonal TV and an equation for diagonal UW. All you have to do is set them equal to each other and solve for x. This is really just a exercise in making sure you know how to do algebra. But then it does say you want the length of the diagonal too, so we'll have to substitute that back in. Okay, so for 13, we are going to set 3x equal to 5x minus 10. Okay. And we are going to subtract 5x from both sides. Okay, and that's going to give us negative 2x equals negative 10. We're going to divide both sides by negative 2 and get that x equals 5. Okay, but x doesn't just equal 5. We need to substitute this 5 back in here. The diagonals are congruent, so once we find one, we've got them both. No. Freehand. Okay. We know for 13 that x equals 5. Okay, so we're going to substitute that back in here. And know that the diagonals are 3 times 5 then. Which is, of course, 15. Okay, so the diagonals are 15 units long on number 13. Okay? So 14, same exact situation. And it's going to be true on 15, 16, 17, and 18 also. Okay, so for 14, I've got 2x minus 4 equal to x plus 10. I'm going to subtract x from both sides. I'm going to do a couple steps in a row here. If I'm subtracting x from both sides, that means I'm moving my x's to the left. So I'm going to move my constants to the right and add 4 to both sides. Okay? I wonder if this is just too big. Add 4 to both sides. So over here, I'm going to subtract x and add 4. Okay. So let's see what that does. And I think I can show this with freehand just fine. Okay. So on the left side, I'm canceling out the 4s. On the right side, I'm canceling out the x's. Oh, that did work out. Okay. So now we have 2x minus x, which is just x. On the left side, on the right side, 10 plus 4, which is 14. Now that we know what x is, we can substitute that back in and find the length of our diagonals. So here I have that x is 14. I'm going to plug that right back in right here. Okay, and I know that our diagonals are 14 plus 10, which is 24. That looks like a Z. You know that's a 2, right? That's a little bit better. Okay, and 15 was the length of our diagonals here. Okay, 4 more. And I'm wondering if I not only need to change color, but I also might need to change font. Maybe not. Okay. All right, on 15, I've got 6x equals... Oh, I know what I could do to make this a little bit better. No, I don't want to do that. Okay. 6x plus 4 equals 4x plus 8. Again, I'm going to do 2 steps in one to make sure that I have plenty of room here. I'm going to subtract 4x from both sides, which means moving my x's to the left, which means I'm going to move my constants to the right by subtracting 4 from both sides. So I'm going to subtract 4x and subtract 4 from both sides. Again, let me show you what that does for you here. Okay. My 4's cancel out on the left, my 4x's cancel out on the right. Excellent. Okay, so I have 6x minus 4x on the left, which is 2x. And on the right, I have 8 minus 4, which is 4. So all I have left to do is divide both sides by 2, and I get that x equals 2. Now that I know that x equals 2, I can substitute that back in, which is super handy. X equals 2 here. So I'm going to pop that back in right up here. Okay. And I'm going to, instead of saying 6x plus 4, I'm going to say 6 times 2 plus 4, which is 12 plus 4. A little more room here. 12 plus 4, which is 16. Okay, so that's going to be the length of our diagonals for number 15. Okay, so just to make sure that you know what I'm doing here, it says find the value of x and the length of each diagonal. So I found the value of x, and then I substituted that back in. And then the single number that I'm circling in each one of these is the length of the diagonal after I have substituted that x back in. All right, 16. On 16, I am starting with 7x plus 6 equals 9x minus 18. Okay, so I am going to subtract 7x from both sides. And when I'm subtracting 7x, I'm moving my x's to the right. So I'm going to move my constants to the left by adding 18 to both sides. Okay, subtracting 7x from both sides and adding 18. Always do the exact same thing to both sides. I'm sure some of you remember that from algebra. So my x's are going to cancel out on the left, and my constants are going to cancel out on the right. Perfect. And on the left side, 6 plus 18 is 24. And on the right side, 9x minus 7x is 2x. So the last thing to do here is divide both sides by 2, and I get that x is 12. Now that I know that x is 12, I can substitute that back in to one of these wonderful equations. X is 12. So I'm going to take that. I think I'm going to take that to this one. Okay. So instead of saying 7x plus 6, I'm going to say 7 times 12 plus 6. 7 times 12 is 84. Is that right? 84. Yeah, plus 6. So then my final value for my diagonals is 84 plus 6, which is 90. 90 then is the length of my diagonals. 2 more problems. How about some green? Have we used green in this lesson yet? I don't think so. Let's do that then. Green. Okay. For 17, we are starting with setting our equations equal to each other. So I am starting with 8x minus 2 equal to 5x plus 7. So I'm going to subtract 5x from both sides, and in doing so, I'm moving my x's to the left. So I'm going to move my constants to the right by adding 2 to both sides. Subtract 5x from both sides and add 2. So what that's going to do, and I hope that you guys are okay with what I'm doing here. Canceling constants on the left, variables on the right. Nice. And on the left side, I have 8x minus 5x, which is 3x. And on the right side, I have 7 plus 2, which is 9. My last thing to do here then is to divide both sides by 3, and I get that x equals 3. Now that I know that x equals 3, I will just pop that right back into either one of these equations. Doesn't matter which one, because my diagonals are equal anyway. Okay, so I'm just going to pop that back in right here. Color sure is helpful, isn't it? So instead of saying 8x minus 2, I'm going to say 8 times 3 minus 2, which is 24, minus 2, which is 22. And that's going to be the length of my diagonals for number 17. One more question. We've got this. So on number 18, I am starting again with setting my equations equal to each other. So I have 10x minus 4 equals 3x plus 24. Okay, so I'm going to subtract 3x from both sides to keep my x's positive. So I'm moving my variables to the left, which means I'm going to move my constants to the right by adding 4 to both sides. So I'm subtracting 3x and adding 4 to both sides, which means my constants are going to cancel out on the left, my variables are going to cancel out on the right. And on the left I have 10x minus 3x, which is 7x. And on the right I have 24 plus 4, which is 28. Beautiful. Something that's divisible evenly. So I'm dividing both sides by 7. 28 divided by 7 is 4. So now I have a value for x, which is a good thing, because I need to pop that back into one of these equations. So if x is 4, I think I'm going to put it back into this one. I can multiply by 10, and that will be nice and tidy. Instead of saying 10x minus 4, I'm going to say 10 times 4 minus 4, which is 40, minus 4, which is 36. So now I also have the length of my diagonals for that one. Isn't this fun? So you can watch this over and over again if I went too fast. If anything was unclear, please take the time to watch this again. That's why we're doing these things, okay? So I hope this has been helpful. I am going to save this and then go record 6.5. All right. Thank you all so much.